Hello everyone, this is Shrikar here, and today we'll be building a simple application using CrewAI for paper research. So I got motivated by watching this like a new course from deeplearning.ai, which talks about how to build like custom agents or multi agents using CrewAI. And for this particular simple application, I actually wanted to talk about the use case. So the goal is like, let's say if you want to understand a research paper, like every research paper has the main theme. Along with that, it also has a list of like citations that it provides to. So the goal here is like, can we create like a research agent that, first of all, given a link, link to the paper, can it understand the paper and understand or extract the key citations from that paper and then download them and then summarizes the cited paper and also use the main paper along with the cited paper to create like a consistent content for understanding what the paper is doing. So this is like the whole flow. Like we have a crawler agent, we have a research agent, and then we have a senior researcher who kind of like aggregates all this information and then creates like a slide content. So to begin with, let's look at the code here. So for people who are aware of CrewAI, CrewAI provides like three simple kind of like tools or like components. One is called the agent, one is the task, and the crew. So you can think of crew as like a list of agents working together to solve a particular set of tasks. As you can see, like if you think of this particular main Arxiv paper link, you can actually say that this particular crawler actually downloads the paper, and also it'll in this case it's actually like using a tool. So if you look at the tool, all it does is I'm kind of like using the Python package for which will kind of like pull the paper, download the paper to the local folder, and then use a PyPDF to essentially extract the content and return back the content to the LLM, or in this case the Crow. So this is where the first one is. It's probably here. Yeah. Take a link to the URL. Take a look at the last. So normally, like if you look at how the paper uh, path is or the pattern is, it has this URL and by a particular ID. So all we need is this ID, and then we can download the PDF and then read the content. That's essentially what this particular tool is doing. So the next one is essentially like the junior researcher. All this particular agent does is it takes a look at the content that is provided by the crawler agent, and then it extracts the citations and then use another tool called the multi-paper extractor to download the same similar PDF. So, for example, a single paper might have multiple citations, and this particular tool will essentially download all of them and provide the content from those cited papers. So that is essentially what is happening in this particular junior researcher. Then this is like the final researcher, who's kind of, you can think of like give as a role as senior researcher and educator. The goal of this particular research agent is to essentially like combine all the data from the current paper and the cited paper, and then provide like consistent content that we can read up on to understand more about what the paper is trying to explain. So this is essentially what the three agents are, and for every, you can think of as for every agent there's probably a corresponding task, and this is essentially the crawl task, which kind of like takes in the link and then extracts that information and then returns the data. Similarly, we have the cited paper researcher, which essentially does the same thing. Again, in this case, we kind of like hook the particular task to a particular agent, and also you can actually be very very specific about the output schema in which you want the output to be. For example, in this case, I want the output to be like something like this, where it has a paper name, paper URL, paper content, and any citations. So this is like the cited papers researcher task, and then we have the final researcher task. So this is essentially the place where all of the information that is like kind of like extracted from the previous two tasks are kind of like aggregated, and then you provide the final output. In this case, I'm telling this particular task provide like a high level overview of the paper and the core contribution. Also, I kind of like specifically say, please generate the content for presentation, don't include more than 15 slides. include content which you think are important things for important things that readers should know about the paper. Double down on the paper, on how this paper is better than the existing methods, anything that is unique, or any kind of like novelties that this paper brings in. I also specifically they use first person POV to tell the story, provide the content in a markdown format that I can just copy and paste. So if you look at this particular agent, it's very simple. So all it does is essentially like, if you think of the same task to be done in ChatGPT, you probably have to download the all the citations yourself and then append it to the ChatGPT session, and then you can kind of like generate similar thing. But I was thinking if it's possible to do it with agents. So let's see. Let's actually talk a little bit more about tools. Tools is nothing but kind of like utility functions that does like one thing and one thing specific. In this case, it's essentially downloading the paper or extracting the paper, and similar utilities. Actually, Crew.ai has a bunch of them. So if you go to CrewAI, if you in this section you have a bunch of documentation where it kind of like talks about different tools, like what other agents, crews, flows. I think flow is something that they added very recently. Training, and a bunch of other things. But as an example, let's see how the tool works. Let's clean this thing up. Clean it here. I'm going to say Python, so paper.py. So for this particular example, I'm just looking at the event-based product carousel recommendation with query click graph. This is a paper from Walmart. Let's see how the tool actually works. So if you look at this scenario, like this particular execution, it's actually downloading the first paper. Oh, there's a lot of content here. The verbose probably makes it a bit more extreme, but let's expand this to see if we can get more information. So you have like now it's probably pulling in other papers also. For example, this is like a junior researcher task. I need to assemble the full content of the current paper along with the abstracts and summaries of the cited paper. I have the content of the current paper, and I will extract the details of cited paper to complete the final answer. Right now, if you see this particular example, it kind of like passes the paper names, which are the three cited papers in the current paper. And what it will tell us, like if you look at the tool definition here, in the tool definition for the multi-extractor, you actually get a paper names that is like a list of string, which is essentially a list of paper names, right? So it kind of like pulls, if you look at the output from the junior researcher, it kind of like talks about, okay, the current paper, introduction, related work, what is unique about this particular paper, but along with that, it also provides references. What is the summary of this particular paper, like individual three or four papers, it will kind of like provide some information on that, and then it passes on to the senior researcher or the senior researcher and educator, which essentially creates this graph like the slides for us. For example, in this case, it mentions that slide one should include introduction to the event-based recommendation. Focus like should be enhancing user experience by tailoring recommendations to events like festivals, occasions like something like Father's Day, Valentine's Day, July 4th, and whatnot. I kind of like there's also like challenges about how the normal recommendations don't kind of like respect or don't tailor are not tailored to the event or like temporal events. And along with that, it also provides like different product relevance of the different product carousels, essentially like all the content that we need for generating our slides. Yeah, again, in this case, it's kind of like telling, okay, the proposed solution, the query click by pattern graph. What is like innovative in that is essentially using query click graph to a certain events aspects and the related products. So it also talks about like how it's better than the manual curation. So I think that's essentially what they used as a baseline, if I remember correctly. um yeah, event centric comparisons with existing systems. Okay, unlike static or simple recommendations, leverages dynamic graph analysis, better scalability. uh, Yeah, I mean, this is like high level overview of how you can use some agentic frameworks, in this case Crow AI, to provide like the slide content, which kind of also is useful for our research purpose. Yeah, thank you, folks. Please let me know if you have any questions. And also, one more point about this particular tooling is, if from the cost perspective, I think you can actually even try running it on like local models. I tried, but it was very slow on my laptop. But for this particular paper, like research agent, it takes like around 6 to 7 cents per cycle. In the sense, like for a per research paper, it actually downloaded and like extracted a lot more content. But yeah, it's like 5 to 6 cents per for per research. But yeah, let me know if you have any questions. Thank you.